Hi, this is Hari Babu, working as Associate Professor in EC Department of MLR Institute of Technology. Today, I want to discuss about problems related to probability distribution and density function. See here, the random variable x has the discrete random variable in the set -1, -0.5, 0.7, 1.5, 3 with corresponding probabilities are 0.1, 0.2, 0.1, 0.4, 0.2. So now I need to find distribution and density function of these random variables. See here, first of all, I need to prepare the table for this one. That is x and p of x. Here, x -1 with probability 0.1 and -0.5 with the probability 0.2 and 0.7 with the probability 0.1 and 1.5 probability is 0.4, 3 probability is 0.2. So this is the given data. Now I need to find probability distribution function and probability density function. So here what is meant by probability distribution function, density function? So here probability distribution function means the cumulative sum of all the probabilities of the random variable up to x is called as probability distribution function. That is defined as capital Fx of x equal to p of x less than or equal to x. Here my random variable x is discrete random variable only. Okay. Now I need to find probability distribution function. That is, I want to write that one. That is x and p of x -1 with 0.1 and -0.5 with 0.2 and 0.7 with 0.1, 1.5 with 0.4 and 3 with 0.2. Here x is discrete random variable. First I need to find probability distribution function. That is capital Fx of x equal to p of x less than or equal to x. Now I need to find x equal to -1 value. So we can write capital Fx of -1 is equal to p of x less than or equal to -1. So my probability is 0.1 only. I need to find x equal to -0.5. That is capital Fx of -0.5 is equal to p of x less than or equal to -0.5. So x less than or equal to -0.5 means I can write -1 probability and -0.5 probability. That is p of x equal to -1 plus p of x equal to -0.5. That is 0.1 plus 0.2. That is 0.3. Next one, x equal to 0.7. That is capital Fx of 0.7 equal to p of x less than or equal to 0.7 means p of x equal to -1 plus p of x equal to -0.5 plus p of x equal to 0.7. That is 0.1 plus 0.2 plus 0.1. That is 0.4. Next, I need to find at x equal to 1.5. That is capital Fx of 1.5 is equal to, simply we can write p of x less than or equal to 0.7 plus p of x equal to 1.5. That is previous value is 0.4. Now current value is 0.4. That is 0.8. Next one, I need to find the probability distribution function at 3. That is capital Fx of 3 equal to, I can write previous value, that is capital Fx of 1.5 plus p of x equal to 3 value only. Fx of 1.5 means my value is 0.8 plus this value is 0.2. So total answer is 1. Now I need to draw the graph for this one. So here, if you want to draw the graph means this is my random variable x. This is my probability density distribution function. Here -1, assume this is the -1. At -1, my voltage will be taken as 0.1. This will be continuing up to the next sample. My next sample will be taken as -0.5. So here same value is continuing up to this one. Next, at -0.5, my voltage is 0.3. So here my voltage is 0.3 up to the 0.7. Next sample, assume this is point sample. This voltage is 0.3. Next, at 0.7, my voltage is 0.4. So here my voltage will be increasing up to the 0.4. Next, at 1.5, my voltage is 8.8. Next one, at third sample, my voltage is 1. So this is the probability distribution function. Next, I want to find probability density function also. Same I need to represent, that is x and p of x. So here x values, that is -1, 0.1, -0.5, that is 0.2, 0.7, that is 0.1. Next 1.5, 0.4, 3, 0.2. For this one, I need to find probability density function. So here probability density function means I need to represent the value at the given random variable x only. That is, small fx of x is equal to summation of I equal to 1 to n p of xi into del of x minus xi. That is p of -1, that is p of -1 into del of x minus of -1 means del of x plus 1 plus p of -0.5 into del of x plus 0.5 plus p of 0.7 into del of x minus 0.7 plus p of 1.5 into del of x minus 1.5 plus p of 3 into del of x minus 3. See here, p of -1 means my voltage is 1 into del of x plus 1 plus 0.2 into del of x plus 0.5. P of 0.7, that is 0.1 into del of x minus 0.7 plus p of 1.5 means 0.4 into del of x minus 1.5, and p of 3 is 0.2 into del of x minus 3. So this is my probability density function. Now I want to draw the graph for this one. So this is my random variable, this is my x-axis. Here my values will be taken as -1, -0.5, 0.7, 1.5 and 3. At -1 my voltage is 0.1 only. At -0.5 my voltage is 0.2. At 0.7 voltage is 0.1 only. And 1.5 voltage is 0.4. And at 3 voltage is 0.2. So this is the representation of graph for the probability density function. Next one, we need to see another problem related to that one only. See here, if the probability density function of the random variable is given by fx of x equal to k into 1 minus x square for 0 less than x less than 1, find the value of k and probability distribution function. In that case, he is giving probability density function. By using that one, you need to find k value and probability distribution function. This problem is related to continuous random variable. See here, the range is given. My random variable is varying between 0 to 1. Range is given. So now how to find k value. Density function is given, range is given. How to find the k value means, or constant value means, we need to use the area under the density function is equal to 1. That is, integral of x equal to minus infinity to plus infinity fx of x dx must be equal to 1. This is the property to find the constant value. See, integral of x equal to, here lower limit is given as 0 and upper limit is given as 1, with my density function is k into 1 minus x square with dx is equal to 1. Now I need to apply the integration for this one means, here k is the constant, integration of 1 is x, and integration of x square is x cube by 3 from x equal to 0 to 1 is equal to 1. That is k into, I need to substitute upper limit and lower limit. Instead of x, I need to substitute upper limit, that is 1 minus 1 power 3 minus by 3 minus of 0 minus 0 power 3 by 3 is equal to 1. That is k into 1 minus 1 by 3 is equal to 1. That is k equal to 3 minus 1 by 3 is equal to 1. That is k equal to 3 by 2. So this is my constant value. So simply I can define my density function is fx of x is equal to 3 by 2 into 1 minus x square for the range of 0 less than x less than 1. This is the given density function. For this given density function, I need to find distribution function. Okay. See here, small fx of x is equal to 3 by 2 into 1 minus x square from the range of 0 less than x less than 1. How to find the distribution function? We know already third property of probability density function, that is, the distribution function is equal to integral of x equal to minus infinity to x small fx of x dx. This is the third property of probability density function. So now I need to find fx of x is equal to integral of, what is the lower limit for this one? My lower limit is 0. What about upper limit? I need to find the random variable of the probability density function up to x. So I am writing same value on it, that is x only. X with my density function is 3 by 2 into 1 minus x square with the dx. Here 3 by 2 is constant means, that is 3 by 2 into 1 integration is x and x square integration is x cube by 3 from the range of x equal to 0 to x. Now that is 3 by 2 into x minus x cube by 3 from the range of x equal to 0 to x. This is my capital fx of x. That is, capital fx of x distribution function is equal to 3 by 2 into, you need to substitute upper limit and lower limit instead of x. That is x minus x cube by 3 minus 0 minus 0 power 3 by 3. That is 3 by 2 into x minus x cube by 3. This is my probability distribution function. I want to write the limits of this function means, capital fx of x is equal to 0 for x is less than or equal to 0. If capital fx of x is equal to 3 by 2 into x minus x cube by 3 for 0 less than x less than 1. Here, if x value is greater than 1, always 1 only. So this is my probability distribution function for the given data. It is fx of x equal to 3 by 2 into x minus x power 3 by 3 for 0 less than x less than 1. Next one, we need to do similar problem only. See here, the probability density function fx of x is equal to a into e power minus b into mod x, where x is a random variable within the given range. So here we need to use the range will be taken as 0 to 1. 0 less than x less than 1. Find the cumulative distribution function and the probability that the outcome x lies between 1 and 2. See here, I need to find probability distribution function. Here cumulative distribution function and probability distribution function both are same only. So now I need to write capital Fx of x is equal to, by using third property of probability density function, we can write integral of x equal to minus infinity to x small fx of x with dx. Okay, so now I can write capital Fx of x is equal to integral of, my lower limit will be given as x equal to 0 and my upper limit will be given as same x only, x with a into e power minus b into mod x with dx. First of all, I need to define what is meant by mod x, how to write that mod x. See here, generally this is my random variable. Here this will be taken as negative axis, this is the positive axis. In the negative axis, mod x will be treated as minus x, and the positive axis mod x is treated as plus x. So now I can write capital Fx of x is equal to integral of x equal to 0 to x, that is a into e power minus b into mod x, that is mod x into dx. For this one, first of all, I need to find probability a and b values. I need to find what is the relation between a and b values and what is the probability density function. For example, I am assuming my x value will be taken as greater than or equal to 0, positive value only. Here my x will be taken as positive value. So what I can write, capital Fx of x equal to integral of x equal to 0 to x, why? Because I am using positive value only, into a into e power minus b into mod x. Mod x will be taken as plus x, na? That is plus x with dx. So now we can apply the integration for that one, means that is a into e power minus bx divided by, apply the differentiation for this total term with respect to x only, that is minus b, from x equal to 0 to x. So we can write a into e power minus x minus e power minus b into 0 divided by minus b, that is a into e power minus bx minus e power 0 means 1 by minus b, that also equal to a into, I want to take common minus 1, means simply we can write a by b into 1 minus e power minus bx. This is my probability distribution function for the given one. Now I need to find second one. What he is telling, the probability of the outcome is lies between 1 and 2. For that one, what will happen? So here first of all, if you want to find this one, means I should know probability distribution function. So here what he is telling, here my x value lower limit is 1 and my upper limit will be taken as 2. In that case you need to find probability of that function. See here, I know capital Fx of x is equal to a by b into 1 minus e power minus b into x only. In that case, I need to substitute Fx of, that is you need to find p of x1 less than x less than or equal to x2 equal to I can write capital Fx of x2 minus capital Fx of x1. That is, here x1 will be taken as 1 and x2 will be taken as 2. This will be taken by using the probability density function fourth property. That is P of 1 less than x less than or equal to 2 is equal to Fx of 2 minus Fx of 1 only. So here a by b into 1 minus e power minus 2b minus a by b into 1 minus e power minus b. So simply we can write a by b minus a by b into e power minus 2b minus a by b plus a by b into e power minus b. Here minus a by b plus a by b both are cancelled. That is a by b into e power minus b minus e power minus 2b. So this is the finding the value between 1 less than or equal to 2. So this is the probability, finding the probability between 1 and 2. Yeah, thank you.